Check out these funny animals, right? They get things, but they swipe things, but they don't return it back. Oh my goodness. Even in probability, sometimes we take things, sometimes we return, sometimes we don't return. That's why the probability changes. You're going to call that the dependent and the independent. Are you ready? This is our lesson for today. Okay, so the topic for today is the probability of compound events. The probability of the first event followed by the probability of the second event. Okay, the basic rule here is that sometimes we get things and we return it back. Okay, but sometimes we get things but we don't return it back. This one is called the independent. Okay, because you return it back. But if you don't return it back, it is now called dependent. And for both, the rule is simply the multiplication rule. Just multiply the first probability times the second probability. But these two will change the numbers. Let's read some key points. Compound probability is concerned with the probability of more than one event occurring. Sometimes event 1, there could be an event 2, there could be an event 3, but don't worry, you'll just need to multiply them. Compound events could be independent, meaning you replace it, or dependent, you take it back. Independent compound events. Okay, this is it, the multiplication rule. Simply multiply the probability of getting A times the probability of getting B. Okay, that's for independent. But for dependent, this is the most important thing. Okay, you multiply the probability of getting A times the probability of getting B, assuming that A was taken out. Taken out. Okay, there's gonna be a subtraction here. Subtraction. Okay, we will understand that better through the following examples. Okay, so we'll understand this better with this word problem. Let's start with this. A bag contains 3 red, 3 blue, and 3 yellow marbles. So you have to grab some marbles inside and blindfolded. You can't see what's inside. What is the probability of drawing a blue marble followed by a yellow marble in that order when you draw 2 marbles from the bag with returning? After getting one, you return it back. This one's easy. Check this out. Okay. Probability of getting a blue is, let's write it down. 1, let's count it. 1, 2, 3. So let's write 3 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 out of 9. 3 out of 9. Are we good? But after getting that blue, remember you took one blue, you put it back. You return it back. Okay, so the number is still there. It's still a, yes, it's still a 9. So let's write it down. The probability of getting a yellow will now be, let's count the yellows. 1, 2, 3. So let's write 3 out of, what is our total again? 9. Okay. So what is the multiplication rule? Simply multiply the probability of getting a blue times the probability of getting a yellow. So that becomes 3 nines times 3 nines. If you want to simplify it, that's what? 1/3 times 1/3. That's going to be 1/9. The probability of getting a blue followed by a yellow is 1/9. 1 out of 9. So what can you say? That is less likely. Likely. So how is it different for dependent? Getting a blue and then followed by a yellow, but after getting the blue, you return it back. Okay, let's write it down. Probability of getting a blue is what? Just like before, 3 out of 9. Okay. Now, you are assuming that the blue was taken away. You're assuming that the blue was taken away. Now, what is the probability of getting a yellow? Let's count the number of yellows. 1, 2, 3. It's still a 3. So let's write down 3. But look at my denominator now. what will my denominator be? 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to use 9. I'm going to use 8 because you're assuming that the blue was taken away already, right? So the probability, the final probability would be the probability of getting a blue times the probability of getting a yellow. So what do? I use my multiplication rule. By the way, we can simplify this as 1/3. Okay, so let's use 1/3 for the blue times 3/8 for the yellow. That becomes, you can cancel that, 1, 1. So 1 out of 8. Okay, so that's it. Again, it is less likely. Now let's try another example so that you would understand it better. A box contains cards with the letters M-A-T-H-E, M-A-T-I-C-S written on them. Okay. What is the probability of drawing a card with the letter M followed by a card with the letter T with replacement? You take, you put back. Okay, that's easy. So let's start with the probability of getting an M. Let's count everybody. That's 1, 2. There are only two letter M's out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 out of 11. But you didn't take that M. You put it back. Okay, so I put it back. It's complete again. So how many letter T's do I have? 1 and 2. 2 out of how many? Again, 2 out of 11. 2 out of 11. What do I do with the two probabilities? I multiply them. 2 times 2 is 4. 11 times 11 is 121. Okay, that's the probability. Now, let's try the dependent. The probability of getting an M, just like before, 2 out of 11. So, assuming that we took one of the M, not both, just one. Assuming you took one of the M, how many T's are there? 1, 2. Yes, it's still going to be a 2. So I put a 2 over here. But my total below will not be 11 anymore. What would it be? It's going to be, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because you're assuming that M was taken away out of 10. So what do? I multiply them. 2 times 2 is 4. 11 times 10 is 110. Okay? So see, different probabilities. One is dependent, one is independent. Now, let's try these problems. A bag of candy contains 4 lemon sour, 5 lime flavored sour balls. If team reaches in and takes one out and eats it, and then 20 minutes later selects another and eats it as well, what is the probability that they're both lemon flavored candy? So we want, is it lemon followed by a lemon? But first thing, is it dependent or independent? Think first. You took one, eats it. If you eat it, is it dependent or independent? You don't replace it anymore. So this will be dependent. Dependent. Okay? So let's start with the probability of getting the first lemon. How many lemons do we have? 4 lemons. So that's going to be 4 over the total. 4 plus 5 lime. Okay? So a total of 9. So 4 out of 9. Okay? But assuming that one lemon was taken already. So what is the probability of taking the second lemon? Assuming that one lemon was already out, so there are 3 lemons left. Okay? Out of what? 8. Got it? Why is it 3? You're assuming one lemon was taken and our total is not 9 anymore. It's already an 8. What do I do with the 2? Just multiply them. 4 nines times 3 eights. Guess what? I could simplify this. Divide by 3, 1. Divide by 3, 3. So that I don't need to reduce to the lowest terms. 1 times 4 is a 4. 3 times 8 is 24. but I could still reduce that. Okay, divide by 4 is a 1, divide by 4 is a 6. So my answer would be 1 out of 6. The probability is 1 out of 6. Okay, let's read this next problem. Mary has 4 dimes, 3 quarters, and 7 nickels in her purse. She reaches in and pulls out a coin, only to have it slip from her finger and falls back into the purse. Then she picks out another coin. What is the probability that she picked a nickel on both tries? Remember, it slipped back. So it went back. Is that dependent or independent? You have to identify that first. Slip back, fall back. So you return it back. It is independent. Independent. So there is no subtraction. Okay, let's do that. So probability of getting the first nickel times the probability of getting the second nickel. All right, the first nickel will be 7 out of, so 4 plus 3 plus 7, that's going to be 14. But guess what? It went back. So how many nickels are there again? There's still going to be 7. And the total will still be what? 14. Yeah. So before we multiply, let's simplify that. Lowest terms is 1 half. Lowest terms is 1 half. Okay, now I can multiply. 1 times 1 on top is a 1. 2 times 2 is a 4. 1/4. It's less than half probability. So what can I say? It is less likely. Less likely. Okay, let's read this problem. Nancy has a $50, a quarter, a dime, and a nickel. One day she picks a coin and puts it into her piggy bank. Pick and put in the bank. Piggy bank. Later on, she chooses a second coin and also puts it into the piggy bank. What is the probability that the two coins totaled 35 cents? Ooh, how would I know that? Okay, but first, dependent or independent? She took a coin. Did she put it back? No. She put it where? Into the piggy bank. Did she replace it? No replacement is what? Dependent. Okay, remember dependent. Dependent. Our total will be decreased by 1 later. Okay, so let's do that. So, but the total should be 35 cents. Half dollar is 0.50. A quarter is 0.25. A dime is 0.10, and a nickel is 0.05. So which two coins will give me a 35? Identify which two coins will give me a 35 cents. A quarter and a dime. Okay, so let's do the probability of getting a quarter. Quarter. The probability of getting a quarter is how many? 1 out of 4. Okay. So next, the dime. The probability of getting a dime, okay, will be what? So assuming you took already a quarter. The quarter is not there anymore. So the dime is there. There's only one dime out of how many total now? Do we still have 4 coins? No, we assume that the quarter was taken away, so there's only 3 left. Okay, so what do? I multiply the 2 and I get 1 times 1 is 1, 4 times 3 is 12. The probability is 1/12. Again, it is very less likely. Got it? Okay, next. A player selects 3 cards from a deck of cards. Okay, find the probability that all 3 cards were picture cards. Just select 3. When you get 1, do you put it back? No, just select 3. When you select 3, did you return the first one? Did you return the second one? No. So no returning. No return. What do you call that? That is, you are what? Dependent. Yeah. Dependent. So there is subtraction, -1 later. Okay. So how many picture cards are there? That is the Jack, Queen, King, right? And there are 4 suits. Jack, Queen, King. So 3 times 4, it's a 12. Okay. remember, in a set of cards, there are 52 set of cards. Probability of the picture card, and then the probability of the next picture card, the probability of the next picture card. Okay. Assuming that you already took one picture card, so there's not going to be 12 anymore, there's going to be 11. And our total will still be 52? No, it's already what? 51. Are we good? Next, the probability of getting the third card with a picture face is what? 10, because you already took 2. And will it still be a total of 51? No, there's only 50 cards left. Okay, these are the three probabilities. Now I can multiply. Okay, before I multiply, that's a big number. I could divide 52 divided by 4. 52 divided by 4 is 13. 12 divided by 4 is 3. Okay. Anything I could divide this one? I could divide 51 and 3. Divide by 3, 1. 51 divided by 3 is 17. 17. The 10 and the 50 I could divide. That's a 1/5. Divide by 10, divide by 10. Is there anything else I can divide? No more. So I can just multiply the numerator. 1 times 1 times 11 times 1 is 11. So 13 times 17 times 5. 13 times 17 times 5 is 13 times 17 is 221. 221 times 5 is 1105. 1105. That is very, very less likely. Okay, that the three cards you pick are three picture cards. Now let's try these ingenuity problems. Okay, the table shows the possible outcomes for rolling a six-sided number cube and flipping a coin. Heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1, tails 2. Okay, it's all there. What is the probability of getting a number less than 3 and tails? So let's just circle it. Less than 3, all the tails are here. Less than 3 is less than 3 tails, less than 3 tails. So we pick 2. 2 out of how many? 2, 4, 6, 8, 10, 12. 2 over 12 is not in the choice. Why? Because the lowest terms is 1/6. Therefore, that's the answer. Okay? Which describes dependent. Remember, dependent, taking and not returning. Not returning. Okay, let's start from below. Flipping two coins at the same time and getting heads on one and tails on the other. Heads on one and tails on the other. Okay, when you get the heads, it doesn't affect the second one. The second one could also be a head or a tail. So not you. Rolling a six-sided number cube and getting an even number, then rolling the same number cube and getting an even number again. So if you roll a dice after getting an even number, okay, do you think if you roll it again, the even number won't be there? It's still gonna be there. So not that. That is independent. Getting an ace of spade in the deck of cards, putting it back, that means it is independent, not you. Drawing a red marble and a yellow marble at the same time from a bag of marbles. If you take a blue, you don't put it back because it's already there. And the yellow, right? So this is the answer. Okay. Let's read this problem. Maggie's bank has assigned her a temporary 3-digit PIN to use at her ATM card. Each digit is a number from 1 through 5 inclusive, and no digit can be used more than once in the PIN. Which multiplication problem can be used to determine the probability that the PIN she was assigned was 1, 2, 3? Okay, a generic number 1, 2, 3. Remember, the choices are 1, 2, 3, 4, 5. And the probability of getting a 1, followed by a probability of getting a 2, followed by probability of getting a 3. Okay, so that's the what we want to know. So the probability of getting a 1, there's only 1 here, so 1 out of 5. Are we good? So assuming that the 1 has been taken already, you're not putting it back. So if you're not putting it back, it is what? Dependent. Dependent. So something would be subtracted. Next, the probability of getting a 2. The probability of getting a 2, how many 2's do I have? There's simply 1. 1 out of how many? 1, 2, 3, 4. So let's write 1 out of 4. Okay? Assuming that you already took the 2. Okay? You cannot use it anymore. So what's the probability of getting a 3? There's only 1 3 out of what? 1, 2, 3. So we only have 1, 3 out of 3 possible choices. So I multiply them. That's going to be 1 out of 5 times 4 is 20. 20 times 3 is 60. But you don't need to get the answer. You just need to find which expression that would be. This one. Okay, got it? To win a game, Ethan has to roll a sum of 11 or more. Okay, x could be greater than or equal to 11. That's for Ethan. Asher has a better probability than Ethan, which could be the outcome that Asher needs to win the game. Select 3 options. Okay, so for Ethan, the numbers, the sum, other sum of 11 or more. Which of the following numbers would be 11 or more? 6 plus 6 is 12. This is 11. This is 11. That's a 12. So there's only 3 probabilities for Ethan. Okay? So 3 out of a total of 36. 3 out of the 36. Or simply 1 out of 12. Okay. Now, how can Asher win? Asher will win if he rolls a sum of 9. Do you agree? To get a 9, let's check the 9s. How many will get a sum of 9? That's a 5 plus 4. 5 plus 4. 5 plus 4. Which else will add as 9? 3 and 6. 6 and 3. What else will add as 9? So that's 4 chances, right? 4 out of 36. So he wins here. How about selecting a 4? Okay, what numbers will add up to 4? 2 plus 2, 1 plus 3, 1 plus 3, 3 plus 1. So that's a what? 3 out of 36. It's equal to 112. It's the same as Ethan, so not you. How about next? A sum that is less than 5. Which numbers are less than 5? 1 plus 1 less than 5. 2 plus 1 less than 5, less than 5. 4 is less than 5. 4 is less than 5. Okay, 5 will not be enough. 1, 2, 3, 4, 5, 6. So here it's going to be 6 out of 36. Yes, you'll win if it's less than 5. Okay, the sum that is greater than 5, less than 7. Greater than 5 but less than 7 is what? 6. Which of the following will add up to 6? Okay, let's use another color here. Okay, which one will add up to 6? The 3 plus 3, this 2 plus 4, 5 plus 1. Okay, more chances here, right? More chances here. Okay, to get a 6. So this will make you win because that's 1, 2, 3, 4, 5, 5 out of 36. Okay, how about this? Rolling a dice that is greater than 9 but less than 11 or getting a 10. Will getting a 10 make him win? Which numbers will add up to 10? 1, 2, 3. Those two will add up to 10. That's only 3 out of 36. It's just the same as Ethan. So 1 out of 12. So not you. So those are the correct answers. Got it? So remember, results is equal to action plus motivation. Good luck.